Good morning, my dear students. So, in this PPT, I'm going to tell you about the different types of damping and some numerical problems to find the natural frequency. Okay. So, last class we studied about the damping and different types of vibrations. Okay. So, this is definitely these different types of dampings definitions are very important. They may ask you around 2 to 3 mark in the examination. Okay. So, every time they may ask you 2 mark question or define the different types of damping and one problem, numerical problem. Okay. So, second part is to find we are going to find some natural frequency of the different system. Okay. So here so let me understand first what you mean by damping. Okay, so damping, I told you in the previous class also, damping is nothing but what, to dissipate to lose the energy in the particular system is called as damping. Or if you want to say in the standard definition means, so it is a resistance of your body to the motion of a vibrating body or a system is called as damping. Okay, you can take the any particular system in that there is a loss of energy during the motion. Okay, so during the dissipation during the that is running in position. Okay, so that dissipation of energy, that may be our liquid, solid, anywhere, so that loss is called as damping. Okay, so due to damping there will be a dissipation of energy takes place, and the damping controls the amplitude of the vibration. Okay, so this is about what the damping. Okay, so it may be applied by a liquid, solid, internally or externally. So damping can take place at any position, at any system. Okay, so damping is nothing but what, it is a resistance of a body to the motion of a vibrating body or a particular system is called as damping. Okay, so that otherwise you can tell a dissipation of energy in a particular system is called as damping. Okay, so now different types of dampings will be there. That is a viscous damping, Coulomb damping, it is also called as a dry friction, and the third one is a solid or structural damping, or slip or non-linear or interfacial damping. Okay, so if the damping takes place, if the energy loss takes place in the liquid medium is called as viscous damping. Coulomb damping, nothing but there is a two surface. Okay, there are two surface rubbing each other, there is a loss of energy is called as Coulomb damping. Solid and structural, nothing but in molecular material, it will take the damping. Okay, slip and nonlinear means intermolecular energy loss takes place. Okay, these are the four different types of damping. These are very important. Okay, let me study in detail definition of each. Okay, so viscous damping. Okay, when a system is allowed to vibrate in a liquid medium, that is in a liquid medium, such dampings are called as viscous damping. Okay, so even if you take in the even the design lab, you have a spring mass damper system, there will be a loss of energy in some oil, so that is called as a viscous damping. Okay, so nowadays it is most commonly used in almost all the field. Okay, so it occurs for a small velocity in lubricated, that is a sliding surface or a dashboard or a container with a small clearance, etc. Okay, so best example is eddy current damping or piston cylinder type of damping. Even if you check it in the IC engine also, we are going to get this viscous damping. Okay, next one is a Coulomb damping or dry friction. Okay, so it is also called as a dry friction. Okay, why we are going to call it is a dry friction? Because in this damping, even if you rub two surfaces each other, there will be loss of energy. Even if you rub two hands of yours, okay, there will be loss of energy. That is called as Coulomb damping. Okay, so when the definition says, when the two dry surfaces have relative motion, that is a rubbing each other, that is a motion takes place, the friction between the opposites to the motion, such damping is called as Coulomb damping. Okay, even if you take one surfaces, you can take the one component, rub each other. Okay, two component rub each other, there is a equal and opposite motion will takes place, there some energy will going to loss, that is called as Coulomb damping. Okay, so in this type of damping, the force of the friction is always opposite to the direction of the velocity of the mass. Okay, so best example is the friction of the two surfaces occur in a riveted joint. So even if you going to fix in the design of machine element, there is a lot of fixing element will be there. In riveted joint, we are going to get this Coulomb damping. Okay, so normally it is occur in a rubbing of the two surfaces. Okay, so that is called as Coulomb damping. Okay, now third one is a solid or structural damping. Okay, so this type of the damping is due to the internal friction or the intermolecular friction of the molecule. Okay, so in the material, and the resistance is offered by the elastic property of a body. This internal friction opposes the motion, so hence there is loss of energy, that is called as solid damping. Just to remember that there is a loss of energy takes place in a molecular, in a material, is called as solid or structural damping. Okay, so the magnitude of a damping is very small compared to the other three cases what we studied in the previous case. Okay, so due to the vibration motion, the materials are cylindrical stress or energy dissipated due to the intermolecular friction, due to the force, that is a stress. Okay, so this is called as a solid or structural damping. Okay, So next fourth one is the slip or interfacial damping. So this is also very important. The energy of the vibration dissipated in a microscopic slip occurring between the connected member at their interface under the fluctuating load is called as a interfacial damping. We even if you take the any component, okay, so at the end there is the end connection, so there is a loss of energy takes place at the interfacial, that is called as slip or interfacial damping. Okay, so in this the amount of damping depend upon the combination of the material, okay, which material we are going to make that particular component at the end is okay, so it will depend upon that. Okay, the surface roughness at the interface, that is a contact pressure and the amplitude of the relative displacement, so it is called as slip or interfacial damping. Okay, so next one is that is about the four definitions are very important for the point of examination. They may ask you define viscous damping, Coulomb damping, that is a slip damping, and one more is that is a solid interface, that is non-linear damping. Okay, so next topic is the equation of motion to find the natural frequency. Okay, so there are the three methods to find the natural frequency of the particular system. Okay, the natural frequency of the free longitudinal vibration may be determined by the following three methods. Okay, so these three methods we are going to study in the next PPT, but now we are going to solve the problems. Okay, already we studied these in the another PPT. Okay, what do you mean by equilibrium method, what do you mean by energy method, reeling method. Okay, these three are we are going to use to find the natural frequency. Okay, equilibrium method is also called as the D'Alembert principle, and energy method, reeling method. Okay, to if for your syllabus all three methods is there. In examination they may ask you any one method, they will may give one particular system to find the natural frequency, use any one method. Okay, now so in this PPT I am going to solve one problem to find, that is a simple pendulum. Okay, so they may question they may ask you like this. So determine the natural frequency of a simple pendulum considering the mass of the rod. Okay, this is the last line is very important. Sometimes they may ask you neglect the mass of the rod. Okay, so in this problem they are asking what, determine the natural frequency of the simple pendulum considering the mass of the rod. I already told you what you mean by natural frequency, angular frequency, damped frequency. Okay, so omega d is equal to what, omega n is equal to what. Okay, before solving the problem, let me you have to understand the what are the three different methods. Okay, and the notations and the some basic definitions. Okay, so look at the first PPT. Okay, so now question is given, so let us consider the mass of the rod just to draw a simple pendulum. Okay, so let okay, I drawn here on simple pendulum that is fixed at point O. Okay, so that is a rotation takes place in 360, that is in swing. Okay, so here the m is nothing but what, the mass of the that simple pendulum. Okay, so at the mass while rotation, so there are three forces acting on that particular element, that is particular mass, that is called as a bob. Okay, so one is gravitational force, that is mg. So along that another side from original position to that one force, that is the distance of force we can call as. Okay, so that is equal to mg sin theta, and the right hand side we are going to get cos theta. Okay, so here, so this is always this is a basic. So when there is a bob, this is a bob of the bob, and the mass having that is m. So okay, the weight is equal to acting on that particular element, that is mg, and this side is what, mg sin theta, because here we are going to in between angle is called as theta, and this side is mg cos theta. Okay, so and this length from original from length from O to the mass of the bob is what, L. Okay, so and here they are asking what, considering the mass of the rod. So considering the mass of the rod, nothing but just you are going to assume one more mass. Okay, so that is middle of the this total this middle of the that particular dog. Okay, so here this is about the middle force, this is the middle mass we are going to consider, because here they are considering the mass of the rod. Okay, so exact middle means the length is what, L by 2, total length is L, so this is half of that. Okay, the angle between these is nothing but theta. Okay, same here also same, wherever m is there just to m suffix r, that is the mass of the rod. Mr, that is mg, and this side is mrg sin theta, and this side is mg cos theta. Okay, so this is about the block diagram of a simple pendulum. Okay, so let mr be the mass of the rod, and it acts through the center of the rod, that is midpoint of the both the ends of the diagram, that is as shown in the figure. Okay, so now so according to Newton's second law of the motion, okay, so use second law of motion. What is in Newton's second law? F is equal to ma, that is based on that is the external force is equal to forces occur in that existing in the particular system. Okay, so F is equal to here normally I naught theta double dot, okay, is equal to restoring force. Okay, I naught is nothing but what, it is in terms of the angular theta. Okay, it is a, so I naught is equal to what, moment of inertia, that is m into distance. Okay, m L square plus theta double dot is equal to what, it is the middle of the second part. Okay, so 1 by 3 mr L square. okay, is equal to theta double dot is equal to restoring force, that is we are going to get here the two forces, that is minus mg sin theta, that is a distance into length is equal to L. Similarly minus mr g sin theta L by 2, that is middle portion of the mass, okay, but theta is equal to nearly equal to sin theta, therefore minus mg okay, minus mg sin theta is equal to theta, right, as it is minus of mr g L theta by 2, okay. So again here we have the L square both the side, okay, you can take the common here, L square is equal to m plus 1 by 3 mr is equal to theta double dot, okay. So is equal to minus here what here minus L theta g is a common, so inside is m plus mr by 2, okay. So here m plus mr by 3 into L into theta, so remaining right as it is. So here in this side minus m as it is m plus mr by 2 the theta g, okay. This is what this 1 by 3 is nothing but this is a middle portion of the half, okay. We know that distance 1/3 we are going to consider, so I wrote here 1 by 3 mr L square, okay. So next one is right as it is, that is m over plus 1 mr by 3 into L into theta, that is for force into distance, okay, plus similarly write this as it is. So divide L, we want theta double dot only, so divide whole side by L, we are going to get what, so L get cancelled, so remaining is m plus mr by 3 theta double dot plus m plus mr by 2 theta by L, that is g by L into theta, okay. So again you are going to get, again you are going to divide this m plus mr by 3, so you are going to get what, theta double dot plus m plus mr by 2 whole divided by m plus mr by 3, okay, into g by L into theta, okay. So we are going to find this theta double dot, okay. So to remove quotient of that we are going to doing like this, okay. So now the remaining is what, angular frequency. So this is what the center portion, this is similar to what, omega n value, this is omega n value, okay. So omega n is equal to what, square root of m plus mr by 2 whole divided by m plus mr by 2 into g by L, okay. But we have the natural frequency formula f of n is equal to omega n by 2 pi, okay. Already we know that omega n formula is equal to this, so f of n is equal to 1 by 2 pi square root of that, write the formula m plus mr by 2 whole divided by m plus mr by 2 into g by L. So it is in terms of hertz, and angular frequency is equal to radian per second. So natural frequency formula is hertz, okay. So this is about the to find the natural frequency of the simple pendulum when considering the mass of the rod. So here you have to remember the Newton's second law and theta I naught theta, so ml square, this is the original mass and this is the middle mass for the middle, okay. So distance into length, okay, we are going to consider this, okay. Remaining is very simple mathematics you required, mathematics knowledge you required, okay. So this is about what to find the natural frequency of the simple pendulum considering the mass of the rod, okay. Natural frequency always in sometimes students going to write only up to this omega n is equal to, but we have up to you have to write this formula f of n is equal to omega n by 2 pi, then substitute this is about the natural frequency, this is angular frequency, okay. So don't make confused. I hope you understand this, okay. Thank you very much.